Okay, so this is our lesson on combinations part 2, and just a quick review from part 1. And again, make sure you go to part 1 before you start part 2. But remember, a combination of items occur when the items are selected from the same group. The items is used more is no item is used more than once, and the order of the items make no difference. So the important thing here is, remember, a permutation is an ordered arrangement of a given group of items. A combination is a group of items taken without regard to their order. All right, so with permutation, order matters. With combination, order does not matter. Okay? All right, now let's go ahead, and this is in your Canvas course. So if you need to get a copy and print this out, go ahead and do so. All right, and so we're just basically gonna, in part 2, we're gonna look at these examples, and you gotta make sure you listen very carefully to these. All of these should be combination problems, and then in part 3, when we do part 3, it'll be a mixture of combinations and permutations. All right, so number 1, a 5-person committee is to be elected from an organization's membership of 13 people. How many different committees are possible? So you got to notice, does order matter? Order does not matter. So does selecting the 5 people from here matter? The order matters. No, it doesn't. Okay, so person 2 can be selected as number 1, as number 4, as number 5, doesn't matter. Okay, so order does not matter. In all of these cases, order does not matter. So in that case, I'm going to use combination, the formula for combination. Remember, the formula for combination is this. Now, in part 1, we derived how to get this formula, but here's the formula. So it's n factorial. So remember, this is the number of combinations of n items taken r at a time. So n factorial divided by n minus r factorial. And remember, that's your permutation formula, right? But we want to find a combination. So remember, we saw that when we derived this, that we had to divide also by r factorial. Okay? All right, so that's going to give you the number of combinations, the number of list when the order does not matter. Okay? All right, so you're going to set it up like this. So on your worksheet or your test, you're going to say C, and there'll be 13. 13, you have 13 to choose from, and you're choosing 5 of those. Okay, and then use your calculator. Although before we do that, let me just remind you what you're doing here, what this means. So if you were to actually, and this is 13.5. So if you would actually do the work mathematically, let's see what we get. So we get 13 factorial divided by 13 minus 5 factorial, and the denominator is also being multiplied by 5 factorial. Okay? All right, now we get 13 factorial divided by 13 minus 5 factorial is 8 factorial times 5 factorial. So that's your denominator. So your denominator, you notice you have 8 factorial times 5 factorial. All right, now remember what we did. At that point, we did this. So remember, 13 factorial means 13 times 12 times 11 all the way down to 1, right? But you don't do all that. You just look at the largest you see here. So the largest I see is 8. So I'm going to say times 10 times 9 times 8 factorial. I'm going to say divide by 8 factorial and 5 factorial for right now. Okay, so the 8 factorials divide out. Y'all agree? All right. So then I have 13 times 12 times 11 times 10 times 9 divided by, and at that point, I would go ahead. Now, don't make a mistake and say 5 into 10 is 2, okay? Because that's not 5. That's what? 5 factorial. So you got to say 5 times 4 times 3 times 2 times 1. And now reduce. 5 into 5 is 1. 5 into 10 is 2. Then these 2's divide out. Y'all agree? All right. 4 into 4 is 1. 4 into 12 is 3. And then these 3's divide out. And I'm done. So I just got, because everything in the denominator is 1. So 1 times 1 times 1 times 1 times 1 is 1. So just use your calculator. You'd say 13 times 11 times 9. So 13 times 11 times 9 gives me 1,287. Okay, so that's how you would do that by hand. All right, now let's go ahead and use your calculator. So remember how to do that. So what do I press first? From part 1, you should now know how to do that. So on my calculator, what do I enter first? Okay, you got to enter the 13 first. Then you go to probability right here. Then you need the combination formula. So go press your arrow to underline it. Then press equal. Then you got to press 5, and then press equal, and you get 12,087. Okay. All right, and so for the rest of these, I'm just going to use a calculator just to save some time. But it's important, though, that you know how to do this by hand. It's important. It reviews a lot of skills that you may have forgotten from a previous course. All right, number 2. There are 16 standbys who hope to get seats on a flight, but only 7 seats are available on the plane. How many different ways can the 7 people be selected? All right, so the order in which you get into the plane does not matter. All right, so order, again, does not matter, right? All right, so this is going to be combination problem. So there are 16 people, and I'm choosing 7 of those. And so the question is, how many different ways can these 7 people be selected? Okay, order does not matter. All right, so use your calculator again. You're going to say 16, probability, then press equal, then press 7, and 11,440 ways. Okay? All right, number 3. Okay, so number 3, it says this: to win the jackpot in Louisiana Lotto, one must correctly select 6 numbers from a collection of 40 numbers. And if you notice, if you ever did play the Lotto, now, it goes from 1 through 40. All right, so you got to choose 6 of those numbers. Okay, the order in which selection is made does not matter. All right, so that's an easy one. This phrase right here, where it says order does not matter, you automatically know it's a combination problem. And then how many different selections are possible? All right, so you would say there are 40 items to choose from, and you can only choose 6 of those. So how many ways can you choose 6 items from 40? So you're going to say 40, then probability, then make sure you underline your formula for combinations, and then 6, and then notice 3,838,380. So if you actually played the game, let's say you bought 1 ticket, and that's your answer. But if you bought 1 ticket, the chances of you winning the jackpot, the lotto, is 1 out of this amount. So it's a very low number. The probability of you winning is very, very, very slim. Okay, but in the next lesson or 2 lessons later, you're going to talk about probability. All right. Number 4, a book club offers a choice of 9 books from a list of 30. Okay, so in how many ways can a member make a selection? All right, so the order in which you select books does not matter. All right, so again, does not matter. So order does not matter. So you're going to say combination of 30 books to choose from. I want to choose 9 of those. So how many ways can I select 9 books from 30? So again, use your calculator. You say 30, probability, then press equal, and then 9 equal. That's a lot. So let's see, 14307,150. So it's a little over 14 million. All right, so again, make sure you're getting all these numbers. Make sure you know how to use your calculator. Okay, number 5, a chef has 7 brands of hot sauce. 4 of the brands will be chosen to mix into a gumbo. How many outcomes are possible? So the order in which you choose does not matter. So again, that's a combination problem. So you're going to say the number of combinations of 7 items chosen 4 at a time is going to equal. And so you're going to say 7, probability, and then 4 equal 35. So there are 35 ways to choose 4 of these items when order does not matter. Okay, now let's look at number 6 and 7. So first of all, number 6. How many different committees can be formed from 6 professors and 13 students if each committee is made up of 3 professors and 5 students? Okay, now let's look at a simpler problem and then we'll come back to this. All right, so here's a simpler problem. All right, so we're going to do this by hand so you'll understand why we're doing 6 and 7 that way. It's still a combination problem, but these were very straightforward, right? So look, just one combination. You just use the formula once. That's all you did. But here, notice you're selecting 3 professors out of 6, and then you need to select 5 students out of the students. All right, so it's kind of like 2 of these into 1. Okay. All right, so we're going to look at a simple example. Suppose this would be a simpler example. All right, suppose you have 4 male friends. 4 male friends. Okay, and let's call them A, B, C, and D. And you have 3 female friends. And let's call them E, F, and G. Okay, and you're going on a vacation, and you want to go, and you're you can only bring 3 male friends and 2 female friends. All right, so you're going on a vacation. And you can only bring 3 male friends and 2 female friends. Okay? All right, so the question is, how many possible ways are there to choose who will vacation with you? Okay? All right, now here's the idea. So basically, I can choose any 3 of these individuals and any 2 of these, right? Okay, so altogether you have 5 friends going with you, 3 males, 2 female, right? All right, so in other words, I can, in terms of male friends, I can select, so a sample one would be I can select A, B, and C, and then I can select E and F, right? Okay, so these are my 3 male friends, these are my 2 female friends. And the question is, how many of these do I have to choose from, right? Okay. Now, what I want you to understand here is that the order in which I put this did not matter, right? Order did not matter. Order did not matter, meaning this. If I wrote B, A, C, and then F, E, do y'all agree that these are the same people as this? This is the same. Same list. So order does not matter, okay? All right. Now, here's the question though. Let's look at this part and then we'll look at this part. I got to figure out how many choices, how many ways can I choose 3 people out of 4? Okay, so think, how many ways can I choose 3 people out of 4? Okay, all right. So since order doesn't matter, you know that's a combination problem. Meaning that out of 4 male friends, I can choose 3, and then if you use your calculator, you're going to get 4. You're going to get 4. So you can get 4 ways. So let's see if we can find them. So I'm going to go ahead up here. I'm going to list them. So let's find these 4. Find these 4. Okay. All right. So I know one way. So I'm going to go ahead and look at my list again. A, B, C, D. All right. Remember, I can only choose 3. So I can choose A, B, C, right? Those could be the 3 male friends I can choose, or I can choose A, C, D, right? All right. Now, y'all agree that BAC is the same as what I wrote here? So any combination of A, B, and C, any order of A, B, and C is the same as this one. Then I can choose, then I can choose B, C, D, right? I can choose B, C, D. And then, oops, I forgot one of the A's. So I can choose A, B, C. I can choose A, C, D. I can also choose A, B, D, right? And then I went to the B, and the only choice I have is B, C, D. So those are the four right here. Those are the only four possibilities for choosing my male friend. So either I can choose friend ABC, or I can choose ACD, or I can choose ABD, or I can choose BCD. Okay. Now for female, so these are the male possibilities. Okay. Let's look at the female possibilities. All right. So since order doesn't matter, I know that's going to be there are only three of those. I'm choosing two. So if you use your calculator, that's going to be 3. So let's list them. So remember, there are 3 of them: E, F, and G, right? So I can have female friends E and F go with me. I can have female friends E and G go with me. And remember, GE is the same as EG, so don't write it again. EF is the same as FE, so don't write it again. Remember, order does not matter. Or I can have FG. So those are my 3. Okay. So I'm going to go ahead and I'm going to list them again. So here are my male possibilities: A, B, C, A, C, D. I'm going to put A first again. A, B, D, and then B, C, D. So these are your male. Your female would be E, F, E, G, F, G. Okay? So if I list all the possibilities, so let's list all the possibilities. So remember your 5 friends? Your 5 friends, remember, like this right here? The 5 people that can go with me. So I can have A, B, C, and then I can group that with EF. Or I can have A, B, C, those male friends, go with EG, right? I still have 5 people. Or I can have the same group of male friends go with FG. All right. So, or I can have these male friends, ACD, go with EF, and then ACD go with EG. You see what's happening? Okay. Or I can have, make sure I did FG, I forgot FG, ACD with FG. Or I can have I'm going to put that here. Or I can have ABD go with each of those, right? EF, EG, oops, sorry, ABD, EG, and then ABD, FG. And then finally I can have BCD go with any of these. So BCD, EF, BCD, EG, and then BCD, FG. How many are there altogether then? 1, 2, 3, 4, 5, 6. So 6 and 6 is 12, right? So there are 12 possibilities. So basically what you notice is this. So I have 4 ways of picking my male friends, my 3 male friends, and then there are 3 ways of picking my female friends, and then using the fundamental counting principle, 4 times 3 gives me 12. So 4 times 3 equals 12. So this turns out to be the number of ways of choosing 3 people from 4, and this right here is the number of combinations, number of ways of choosing 2 people from 3. All right? So that's going to help us with number 6 now. Okay, so number 6. Okay, so how many different committees can be formed from 6 professors, and remember you're choosing 3, and then 13 students, and you're choosing 5 from those. So that's going to be a combination problem, but you're also using the uh, fundamental counting principle. All right. So you're going to say C, 6 professors, and you're choosing 3 of them, and a combination of out of 13 students, you're choosing 5. Okay, and just use your calculator and see what we get. So that's going to be so 7. I'm sorry, 6 probability, and then you're choosing 3 times 13 probability combination, and you're choosing 5, and you're going to press equal, and you get 25,740. 25,740. Okay? So there are 25,740 committees that can be formed. All right, and then finally, number 7. So the U.S. Senate of the 116th Congress, the one that's in session right now, consists of 53 Republicans, 45 Democrats, and 2 independents. How many committees can be formed if each committee must have 5 Republicans and 4 Democrats? Okay, so this committee has 5 Republicans, 4 Democrats. So you're only looking at Republicans and Democrats here. Okay, so that's all you're looking at. So we're just going to say the number of Democrats times the number of um, Republicans. So let's look at the Democrats first. So out of Democrats, now the order in which you choose these Democrats or Republicans does not matter. So if you do Democrats first, it doesn't matter if you do Democrats or Republicans. It doesn't matter because multiplication is commutative. The order in which you multiply does not matter. So you're going to say 45 Democrats, and you're choosing 4 of those. So that's going to give you how many possible committees there are for Democrats. And then you're going to have 53 Republicans, and you're choosing 5 of those. And then let's see how many committees can be formed with those 2 groups. All right, so you're going to have a list. If you were to list them, like right here, if you were to list them, you have 3 professors, 5 students, so there'll be this many list 8-member committees. So you'd have committee 1 with 8 people, committee 2 with 8 people, committee 3 with 8 people, all the way, and you'd have this many of them. So let's see what this is. So 45 probability, move your arrow, press equal, 4 times 53 probability, move your arrow, 5 equals. Okay, so that's a, remember I made that up, so that's a huge number, right? That's in scientific notation. So all you can do is just say, I kind of, this right here is actually I got that from Google. So if you go and you find out who's on the 16th Congress, you'll see there are 5 Republicans, 4 Democrats. So what I would do then, since this is a scientific notation, is just approximate. So I would say 4.3 times 10 to the 11th power. That's what I would say. So 4.3, I just rounded off, 4.3 times 10 to the 11th power, approximated here. And I remember what that means though. Okay, so that means that if you were to write this out without scientific notation, you would say, all right, so you see where the exponent here is 11? All right, so you move your decimal point 11 places to the right. So it'll be 4, 3, so that's 1, and you go 10 more. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So like 43, so this is millions place, this is billions place, so 43 trillion, something like that. That's a big number, right? Okay. Yeah, so this is pretty big. All right, so that's going to take care of numbers 1 through 7. All right, so The one in your worksheet on my MATLAB, I don't think you're gonna have scientific notation, but if you need to review scientific notation, just Google scientific notation, and then you'll see some videos on that. All right, but I'm not gonna have a problem where you have to use scientific notation, and I don't think my MATLAB has that either. All right, so if you have a little difficulty with understanding scientific notation, it's no big deal, as long as you know how to do this part. Okay. All right, so that's going to be the end of that lesson.